Hello, I'm back again, and this time I'm back in school in my classroom, which is quite nice. We're going to do a little short thing here about greenhouse gases and climate change. Now, we've been looking at how the climate has changed over millions and millions of years on our planet, how it started off being quite full of carbon dioxide. And then through the action of photosynthesis, taking that carbon out of the atmosphere into plants initially, and then they cleared up the atmosphere, allowed some oxygen in there so that animals could come along. And the animals then ate the plants, and the carbon then stores inside the bodies of those animals. And when the animals and the plants full of carbon die, that basically is taken underground if they don't decompose on the surface, and that old carbon has been taken down, buried under the ground for millions of years, turns into coal if it was plants that were down there, turns into oil and gas if it was the sort of the soft bodies of creatures that have died and been buried underground, and if it's the shells and the bones of sea creatures, they turn into chalk or limestone underground. So all of these things are what we call sinks of carbon. They're storing lots of carbon that's underground, and the problems that we have been doing in our modern age is digging this stuff up and throwing carbon back in the atmosphere. So anyway, let's talk today about two things. First of all, greenhouse gases, and secondly about climate change. Now, we tend to sort of talk about these two things together as if as if the greenhouse gases are a new thing. Greenhouse gases are very, very necessary. We live on this planet here, and the average temperature of this planet is 15 degrees centigrade. Now today it's a reasonably warm day and it's about 20 degrees outside, but some places on the earth are hot, some places on the earth are cold. Average temperature on the earth is about 15 degrees. Now space, this stuff all around here, you're looking at around about minus 200 degrees C, sometimes colder than that. So as we know, the heat or thermal energy will go from a warm place to a colder place. And so if we didn't have some greenhouse gases keeping us warm, the temperature on the earth would be, I don't know, about minus 15 degrees C, something like that. So we do need greenhouse gases, and they are naturally here, and they are good because they keep us alive. Now, so let's talk about how they work. So we've got a nice 15 degrees C here. All of the thermal energy, all the heat on our planet comes from the sun, and the rays of the sun, they travel across space 93 million miles, and they get to the earth. And you get light coming from the sun, you get ultraviolet radiation coming from the sun, and you get infrared radiation. And they're all just wavelengths of the same type of energy. We call it electromagnetic waves that send this energy here. So that comes in, that warms up the planet. Some of the energy that comes in is turned into infrared, which is warmth energy or thermal energy, and it comes in, it heats up the planet, and some of it is reflected back off out into space as well. And we've got this balance just about right. If it all was reflected back off into space, the Earth would be far too cold for us to live on. But as it is, we have got some particles in the atmosphere, which we call greenhouse gases. Now, the most common one of those that you know about is carbon dioxide. And what that does, as this thermal energy is trying to escape from the Earth, it will hit one of these particles and come back down. So it reflects it back down into the Earth. A lot of the stuff misses the particles and disappears off into space. And so we have this balance just about right, like a blanket around the Earth that keeps us at around about average temperature of 15 degrees. Now, we are gradually increasing the levels of these greenhouse gases, and obviously if we put more and more in here, then there's more and more of these heat waves that are trying to get out into space are just hitting that and being reflected back in, and it's gradually warming up the planet. So it's a very simple idea, quite a controversial idea, because if we accept that the carbon in the atmosphere is causing global warming, then we have to change our ways of life, and there's lots of people who are very resistant to that. So we've got carbon dioxide that does that. That's not the only greenhouse gas. You have methane here, and increasing levels of methane in the atmosphere behave the same way, and as well as water vapor in the air, that does the same thing. So the big one that we're doing is carbon dioxide by burning fossil fuels. Methane, because of the number of people on the planet and the animals that we keep as well, for example, cows, and cows will fart, and they will fart methane gas. And so if we keep more cows on the planet because we want to eat more cows, we're putting more methane up in the atmosphere, which is a greenhouse gas. Also, from growing rice in paddy fields, there's methane gas comes off of that as they grow in a slightly anaerobic way. And so just by having more and more people on the planet doing things, making stuff, we are increasing this thing here. Okay, and so the greenhouse gases are increasing, and that is causing the global temperatures to rise, and as a result of that, the climate is changing. Not the day-to-day weather, but the general climate, the general temperature of the planet overall is rising. Now, this seems quite straightforward, but there are people who say, no, it's not caused by that. It's caused by something else. And as a scientist, scientists will talk about probabilities, and they will talk about evidence, and you need to be, as a scientist, you need to be able to argue your case, because you can just say, well, it's very clearly happening. You can see there's more carbon dioxide in the atmosphere than there used to be, and the earth is getting hotter and it's causing all of these problems. It's pretty clear. But other people will say, well, we don't know it's causing that. And no matter how maddening that will be, as a scientist, you need to be able to argue your case, and you need to be able to present your evidence and the evidence of other scientists. You need to be able to compare it with the counter arguments that the people that are saying this is not caused by greenhouse gases. Whatever they are saying, you need to be able to argue your case, and that is how science works. And it's quite frustrating for some people, because scientists won't say yes or no. They will say, well, looking at the balance of probabilities, there is a 90% chance that this will happen. People don't want to hear that. They want to say, yes, it is happening, which is why you get some politicians which will say it's a load of rubbish or it's definitely happening. But as a scientist, you need to be able to present evidence, because we are an evidence-based discipline here. Right, that's me rambling on a little bit, but that is the essence of it. Greenhouse gases are a good thing. If we didn't have them, the Earth would be far too cold to live on. But the balance of greenhouse gases is being upset over the last 100 years or so with our massive burning of fossil fuels. And that's the main thing that the overwhelming amount of evidence points towards. And there are other things as well. Okay, I'll see you next time.